Good morning, nerds. Welcome to another installment of Unity Gameplay Basics tutorial series. We're going to look at doing waypoint movement today, which is great for doing something like a tower defense kind of a game. So I'm going to call this one the tower defense tutorial. Although we're not going to have really any towers or any defending, we're just going to learn how to move an enemy through a route. This is great for enemies that need to move through a route, like in a tower defense game. Enemies that patrol, enemies that do a lot of different things. And for this one, I'm going to use a fairly convoluted path, just mostly to discuss and show how we could move enemies through complicated routes. And I think people are intimidated by, oh, there's a lot of different directions and stuff. This is way too much work. We're just going to do like a straight line. And really, you can do, anything between 1 and 50 waypoints is really not any more difficult. So it doesn't really matter. So what I'm going to do is I'm going to start off with my map and my import. Today's art is brought to you by me, and as soon as you guys see it up on the screen, you're going to understand why I don't typically do game art. We're going to start off with, I did create a new scene for this, so I have a tower defense scene. Again, we're not going to really learn the tower defense, and this map isn't as good as it could be for tower defense, but that's okay. Really, I just wanted something complicated to run my tank through. So we're going to start off by putting my tank in. He's a little on the big side, and so what we're going to do is we're going to cut him down. When I made the art, I wasn't really sure what my screen scale was going to be. So my art is a little on the big side. So what we're going to do is we are going to scale that tank down to about 0.5 and 0.5. We're not going to worry about Z-scaling because, frankly, we're just not going to be off the map like that. And we're going to put the tank kind of off screen. So I'm going to get him outside of my space. And actually, just to keep this easier to track for later, I'm going to put the tank way off screen. And this is kind of to represent the fact that in a tower defense game, typically what you're going to see, if this is my screen view here, this rectangle, things don't just appear on the screen and move around, they come in from off the screen. So we're going to start the tank out. And honestly, it really doesn't matter. You can copy my locations here, but the very, very first thing we're going to do is move the tank to a starting location that we want him to be in, and then move him from there. So it really doesn't matter where he is, as long as he's kind of in this top left general area. And the reason top left is when I import my map, which again is far too large, so we're going to scale that by 0.5, 0.5. And your mileage may vary depending on the size of your map, but there we go. Mine was 2048 by 2048, which is a little bit big for this situation. And just to keep this working without me having to mess with settings too much, I'm just going to drag my map over so it's just barely off the screen. Off my left side, so that way when I hit play, what we're going to see is my map is taking up most of the screen space on the left side, which is going to let my tank run through here and go off the screen. Obviously, had I been a little bit more careful about this, I could have made it a better, take up the screen size better, and I could have done some measurements, but this is good enough for a tutorial. So here we go. The next thing I want to do here is actually not touch the tank at all, is plot my waypoints. And that's where the tank is going to move. So if I think about this in terms of waypoints, what we really want to do is think about where is the tank going to change direction. Okay, well, the logical first spot, if my goal is for the tank to come in here and go around this whole mess and up and down and in out these, he's going to leave out to here. So logically, we would think, oh, my first waypoint is here, which is where the first right-hand turn comes into play. But really, my first waypoint needs to be off the screen. I need to get the tank into the map. So really, I want to start my points here and then move through. So we're going to do that. I'm going to create an empty object, and the name doesn't really matter, but I like clarity. So we're going to take this game object, and we're going to just put it right there. And again, it's just kind of barely off the screen. If you are trying to be precise, you could certainly set your positions manually. But honestly, I'm not that worried about precision. The one thing I am going to do, though, is make sure that that z-axis is at 0, which doesn't really matter, but it feels cleaner to me. And while I'm at it, I'm going to look at that on my tank and on my map and just make sure that they're the same. So my game object is there. Again, the name doesn't matter, but I like being clear, so I'm going to name this Waypoint because that feels pretty clear. Now, my pro tip, when I did this in my practice session, I just cloned it a bunch of times and then I started trying to position them. And then I realized that as long as you're working in right angles, it makes more sense to do them as you go. And so what I'm going to do here is just kind of get enough of the map on my screen. So I'm going to kind of zoom out so I can kind of see everything. And this feels pretty good. And here's the trick that I'm going to use. I'm clicked on Waypoint right now. I want to create another one basically straight to the right of it, and about where this turn is going to happen. And one of the tricks with waypoint movement is we are going to put a little collider around them, so you want to overshoot your positioning just a little bit. I'm not going to worry about that this time, but that will help you refine your movement a little. But what I'm going to do now is I'm going to click on my waypoint. Again, just make sure it's highlighted. And I'm going to Control D to duplicate, or Command D if you're on a Mac. And that's going to create a new copy of it. You're going to see the old one's still there, the new one's here. And I can just drag that off to the right, put it where I need it to go, duplicate it again. You're going to see the new one appear here. I'm going to drag this guy down. And I'm just going to keep on doing that to all of my waypoints. So I'm just duplicating out each time I'm doing a Control D. And because this is just a demo, I'm not really worrying about precision here. I would definitely spend some time refining these points if this was a real project or if I was intending to publish. But I'm going to be a little sloppy for time, that you guys don't need to sit here for an hour and watch me meticulously place each point. We're just going to get kind of close here. And for the last one, I'm going to actually position the last one off the screen. So we're going to go out a little ways. Actually, I'm going to go out a lot ways. So that gives me at least a full tank's size worth here. Okay, so now I've got all my waypoints, and if I highlight them all, you can just kind of see, oh, that's not going to work. I need to get some collision in there or something so you can actually see where they are. But if I click on them, I'm just going to use the down arrow to navigate between them in my hierarchy here. You can see I've got my 0 waypoint, which is my starting point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, with that last one being off screen there. 18 different waypoints. So now what we need to do is learn to move between them. And for this, we're going to need a couple things. First off, we need some collision on them because the method that we're going to use involves the tank colliding with the waypoint invisibly. We're going to use trigger collision, colliding with that waypoint, and as soon as he hits the waypoint, detects, oh, I've hit the waypoint I'm looking for, it's time to go look at the next one. And so what we're going to do here is I'm going to highlight all of my waypoints. So I'm going to click on the first one, then I'm going to click on the last one, or other way around, I did the last one and then the first one, but whatever, while holding the shift key, and that's going to highlight them all. I'm going to add a component, and the only thing I'm going to add here is actually I'm going to add a circle collider 2D. And again, we've talked about this before in previous tutorials, but basically you want to use the cheapest colliders you possibly can. So a circle is the cheapest one, so I'm going to use that. And you can already see, hey, look there's all my waypoints. And those circles are really pretty big. If I turn on collision and I have the tank colliding with them, I'm going to be hitting them all the way over here, and that's not going to look good. I really want them to be really pretty little. And so for this one, I'm going to use 0.1. Mostly because at this point I can see them, but honestly I could go as little as 0.01, and 0.1 would be enough for this to work for my code's purposes, but I like to actually be able to see them. So maybe 0.5. Okay, 0.5 I'm actually liking because they're really little, but I can still see them. So I have all my waypoints. Now it's time to look at the tank. What do we need to do there? So the first thing I'm going to do is I'm going to grab my tank, and we're going to do the same thing with him. We're going to give him, and actually I'm going to use a circle collider for him as well. There's no reason I need a box, because all I'm trying to do is hit these other colliders. But just to call this out, a box collider would 100% work here. Any of the colliders would be fine. You don't need a circle colliding with a circle or a box colliding with a box. They can all just collide with each other. I'm just using the circles again because they're cheaper. And the circle collider nicely put a circle around my tank. That looks pretty good, actually. So I'm not going to worry about it. That's about what I would have wanted. So that's pretty great. And then the other thing, I forgot to do this while I was adjusting these, so I'm going to adjust all of them at the same time again, is that these do need to be triggers. If I don't do that, they're going to keep the tank from moving into that space, and that's not what I want. I just want to know when the tank has reached it. Triggers allow you to pass through that collision. It's not a solid object. It just means that it'll detect that collision, although we do need to code that a little bit differently. We need to be aware of triggers when we're coding. Okay, and an object's code, and we're going to talk about this when we get into the coding section, but an object's code is going to be relative. What functionality you use is not dependent on the trigger on the object doing the check. In this case, it'll be the tank looking to see, did I hit something? It's on the object that you're looking to see if you hit. So I can only hit the waypoints if I use the isTrigger code. If they weren't triggers, I would only be able to hit them if I did the not trigger code. Okay, so now that we know that, it's time to go ahead and work on our tank. Now, because this is supposed to be an autonomous object, we're not going to add movement codes. So we don't need to worry about, input directions and key up and key down and key left and things like that. Horizontal, vertical, rather, because that's what we've used for this tutorial series. But we don't need to worry about any of that. We just need to get the tank moving in the correct direction. And so what I'm going to do here is we're going to add a component. I'm going to call this tank script. And you create an add. And we're going to go ahead and double click on that and go into it. Now, so here's some things that we're going to need in order to make this work. The very, very first thing we're going to need to know is we're going to need to teach the tank what waypoints are. And in the next tutorial, we're going to disrupt this a little bit, but there will be just some copy pasting. But for now, we're going to go ahead and do it this way. This is not quite how I would do this in industry. The next tutorial is going to be a little bit closer, but for something simple just to teach pathfinding, this is going to work, and it's close to the same technique. The rest of our code will work fine though. And so what we're going to do is we're going to do public, and we're going to make an array of transforms. So if we think about what a transform is, every single game object has a transform. And including my waypoints and other things. Now, I could make an array of game objects, but then every time I went to a game object, I'd have to find its transform. So for me, it's just easier. Let's just look at the transforms directly. There's no reason not to. So we're going to do public transform, and we're going to do the square brackets after that to make it an array. And what an array is that's a collection of objects. We want a collection of transforms, one for each waypoint. And so this is going to be our way to do this. And we're going to call it waypoints because that makes sense. The other thing we need to know is which waypoint are we looking for right now. Now, since we've started off we aren't touching a waypoint to begin with, and our first waypoint we're going to want to find is this waypoint 0 that's about right here. We're going to look for that one first. So we're going to say public int current waypoint equals 0, because that's the one we're looking for right now. We're also going to need a speed to travel at, so we're going to do public float speed equals, and in this case, I think 30 is about good. We may need to adjust that, but if I remember it, 30 is a pretty good number for this. So now that we've got that down, our start, we don't actually need anything, so we're just going to get rid of this. And in our update, we're going to do some code. And before we get started on this, I spent a lot of time actually last night trying to prep this tutorial. And I was bound and determined to use the built-in nav mesh system to do this. But Unity's nav mesh system has a lot of limitations in 2D, and I couldn't find an easy way to do this without changing it into an XZ program instead of an XY program, by rotating everything 90 degrees, repivoting the cameras, and a lot of other complicated things. My challenge is I've seen some evidence that would support that you could do this using a nav mesh because they've improved the tool. But I haven't been able to find any documentation on that. So if you know an easy way to do this in 2D using nav mesh and still keeping it XY, please call it out in the comments because I want to hear that. I really wanted to do nav mesh. In fact, I spent about 2 hours banging my head on that wall. I love nav mesh. We're going to do a very, very similar tutorial soon in 3D using nav mesh. But for this, I just couldn't make it work. So if you have a solution that works for nav mesh, please share. Otherwise, I'm just going to do it the old school scripting method, which is still pretty fast. Okay, so there's my disclaimer and my callouts. Next up, it's time to look at our update script. And honestly, the code here is going to be, frankly, pretty simple and pretty easy. What we're going to do here is we are going to start off by saying, hey, we want to know, or we want our transform to change, okay, because I want to move my position. And this is a little bit different than using the physics systems that I've been teaching lately, but we're basically going to just move our current position. So we're going to say transform dot position is going to be equal to we're going to create a new vector 2, or actually not new vector 2. We're going to use a vector 2 function called move towards. So we're going to do move towards, and we're going to be moving towards our transform dot position. Move towards is a function that takes 3 components. It takes your current position, or it takes the vector of the current position. In this case, we want our transform.position. Then it's going to need our target destination, which in this case is going to be waypoints, but we want specifically the one that we're looking at right now, which at the beginning of the program is 0, but that's going to change over time. So we're going to say waypoints 0, or sorry, excuse me, not waypoints 0, waypoints current waypoint, which again starts at 0. And that is already a transform, so we just need to know its position. Okay, and if we had done this using GameObject instead, which a lot of my colleagues prefer that method, they would have done public GameObject waypoints, and then they would have done waypoints.transform.position. But I'm just like, hey, we're not going to be using that, so why bother? So we're going to do transform.position, or I'm sorry, just waypoint.position. And then we need to know how close to get to it, or how far are we allowed to move. And for that, we're going to do our speed times our time.delta time. And that is going to give us, that's going to give us our whole deal here. And I am going to word wrap that because I realize how hard that is to see. So let's see here. Visual Studio, if I go to view, I thought you could do it on the view menu. If not, I'll just add some line breaks in there manually, but I thought you could do a line break. So what I'm going to do here is I'm just going to break it over here where the speed is. I thought I was breaking it over there where the speed is. Let me try that again. I'm going to just add a return here. And so this should all be treated as the same line of code, but I've broken it for readability purposes. It won't actually hurt anything to have it on 2 lines like this, and that's why I've got the second line indented, but it's not really good form. So I'm not really a fan of this, but it's fine for readability and for you guys to see at home. But if I was doing this for realsies, I would keep that on the same line. Okay. And then that's it. That's going to get us moving towards it. Now, if we run this, what we're going to see here, I'm going to go ahead and save. And we're going to go ahead and run. And actually, I'm having some IntelliSense problems, so while I'm at it, I'm just going to go ahead and close Visual Studio, see if a reboot fixes it. Okay, we're going to go ahead and run this. And what we should see is the tank getting to waypoint 0. And if we look at this in the scene view, I forgot a couple things. The error message that we're getting here, and this is good practice, is we've got indexes outside the bounds of the array. And I've just got that spamming my console. The reason why that is true is we created this waypoints array, but it has nothing in it, including an element 0, because it's 0 large. So this list is empty here. And there's a lot of different clunky ways that we can do this. I could just hit the plus sign and drag one in, and then hit the plus sign and drag one in. But in this case, I know that I'm going to have a grand total of 19 waypoints. I've got my 0, and it goes up to waypoint 18. So really, I'm going to have 19 in the end. I'm just going to go up here and type in 19 and hit tab. And you're going to notice it put it in, and it just duplicated element 0 a bunch of times. So I have 19 copies of that first waypoint. And so I'm just going to start dragging in, making sure that I get them in the right order. But I'm going to drag in all my waypoints. And this is the time-consuming part. And one of the things where if you make really complicated maps, you're going to start regretting your life a little bit. But here we go. There are some ways you can do this that would make it more automated and procedural, which is really what I would be doing in industry. Is I would make a way for the computer to detect these and automatically add them to the respective lists. But for this, I'm not gonna worry about it. We're just gonna drag them all in. It's only 19 of them. This won't take too long. Okay, so once I've got this done, now we have a populated array that we can work with. Arrays get really touchy if you go outside their bounds, and they always start at 0. So you can see element 0 is this first waypoint here. And the last element in my particular array, it is 19 elements large, but the last element is element 18. And that's, again, because we started counting at 0, it's always going to be kind of like 1 less than the maximum is the last number in it. Okay, so I need to cycle from positions 0 through 18 in order to get to the end. That also means if I count below 0, like for example, if I tried to count to -1, or if I count above 19, I'm going to have some problems. And the first time we do this, we are going to get some error messages because of that. I'm going to show you what they are, what we can expect to see, and then how to get around that. So that's a normal part of this process. Okay, so now when I run, we should get a little bit better result here. What I can see here is on my scene view, my vehicle definitely hit it. I'm there, but now I'm stuck. I got to waypoint, and actually for this, I'm going to split my screen size. That way we can see the game screen and we can see the scene view. I should have moved my camera a little bit so that's centered a little bit better, but whatever. Okay. So let's see, can we do... I'm not going to mess with this. Okay, so what we've got here is we've got our tank. We'll be able to see it at least when it gets over here, but if we look at our views, again, we can run this. And what we definitely do see is the tank, actually he's kind of speeding in, but that's okay. We can see the tank driving towards that, that first waypoint. And he got there pretty quick. I think some of that was compile lag, but we'll adjust that speed a little bit. Actually, I'm going to throttle it down to like, I don't know, maybe 10, just to make that a little bit, whoops, I need to do that while the game is stopped. And we'll go ahead and try that one more time. And it still was really quick, but we'll, as we see him going through the map, we'll adjust that speed accordingly. It's really hard to adjust with the startup time, so we'll deal with that later. That's part of the reason to start off the map is it gives that computer, or gives the game a chance to get that warm up part done. Okay, so let's go ahead and go back into our tank script. I'm going to need to relaunch Visual Studio here due to my IntelliSense problems, but it should load up pretty quickly. Okay. Oh, that's looking a lot better. Okay, so as you can see, I've got my blue highlights and stuff, so IntelliSense appears to be back in operation. That'll help me with some typing. So the next thing that we need to do is teach the game that when the tank hits the first one, we now need to look for the second one. And what we're going to do there is we're going to write some code for the colliders. So we're going to say, we're going to access, this is part of why IntelliSense is nice. If you have IntelliSense working, you can use that to figure out the functions, but what we want is the on-trigger enter. So as it's hitting a trigger collider, we want to start working with it. So we're going to use the, so I'm going to start typing it on trigger. And you're going to see a bunch of different things pop up. I want an on-trigger enter 2D, because this is 2D collision boxes. And you can see that that's loading up. And it puts in a lot of stuff that we need, including this collider 2D collision, which is the collision information of the thing that we just hit. So I could use a get component to get to my own collider, but I now have access to the collider of the other thing, which in this case would be a waypoint. But it could also represent, you know, like anything else I hit. Maybe I got hit by a bullet. Maybe I hit a tower if this is a tower defense. You know, whatever else I may have possibly hit. This is how we read it, as long as that thing that we hit is set as a trigger. Okay, so now that we've got that, what we want to do is, the first thing we need to do is check and see, did we hit the thing we were trying to hit? So I'm going to do an if, and what we're going to do here is we're going to just check the, check it and see if the transform of the thing that we hit is the transform that we're looking for. So we're going to say collision. And we can just do transform. Cool. Okay, so we can do collision.transform. If that is equal to the waypoint of current waypoint, if that's all true, then what we want to do is just increment our current waypoint by 1. And we use the plus plus method for that. So we're going to go current waypoint plus plus. And that's it for code. Like, honestly, that's going to do the entire job of all of our detection and keep us rotating. If we save that, our basic functionality is going to be done. Now, we are going to have some error messages, and there's a couple little things we need to fix. And there's some cosmetic things we want to tweak. But honestly, this is the bulk of the code. Like, we are essentially done with this. That was the hard part. Okay. So if we do this, I'm going to go ahead and hit run. Boy, I spoke too soon, didn't I? It doesn't appear to be incrementing that waypoint. Did I forget to save? I think I forgot to save. Nope, I saved. Okay. Maybe I do need to use the game object. My notes had game object in there. I'm going to try running it one more time just in case it didn't compile correctly, which does happen sometimes, but I may have made a typo or something. Nope. Okay. This is why you should never in a tutorial video be like, and that's it, but until you test it. Okay, I am going to go ahead and just add the game object in here. I had that in my notes, and I didn't do it in the code because I didn't think I would need to. But we're going to try that, and now it more closely matches my existing code. So we're going to go ahead and run that. Oh, I remember what the problem is. Huh. Okay. I did this on purpose to remind you, or to demonstrate this, and then I forgot that I had done it. When we were assembling the tank object, collision only works if physics is enabled. And as we know from previous tutorials, the way you have to enable physics is you have to add a rigid body 2D. So there was nothing wrong with our code. I just forgot a step that I had actually done on purpose and then forgotten about myself. So there we go. But we got rigid body. Again, we need to add a rigid body 2D. And the one thing I am going to do, just because I already know it's not going to be, or it's going to be a problem, is I'm going to change my gravity scale to 0. And that's just going to prevent the tank from falling while I'm trying to do my pathfinding, because this is top down. It's not side to side physics wise. Okay, so now when I run, that collision detection should actually work. That was embarrassing. Hi, I'm a pro. Anyways, and now we can see our tank speeding through. Now the next problem that we're going to see here is in my scene view, I can see my tank speeding through. It is a little too fast. But I didn't see it when it was coming through on the right side. So if I'm gonna call out that for your guys' attention. But what I want to show you is I have my tank highlighted, and we're gonna be able to watch it speeding through over on this side. But when it gets on what should be on the screen on this side, it's not going to show up. So I want you to pay attention to that as we run it. And we should be able to see it about the time it crosses over here, because that's what's in our scene view. And again, the tank is right about here, and we still can't see it. And the reason why, and some of you might be able to see your tanks, so it's probably literally 50-50. The reason why you can or can't see it is it depends on which object was added into your hierarchy first. Because that object is basically behind the other ones. The newer things lay on top of each other. Now, what we want is for that tank to always be on top. And while you can do some hierarchy rearrangement, and it works okay to do it that way, really the best solution here is if we click on our tank and go to our sprite renderer, what we want to do is we actually want to put it a little higher in the layer order. So I'm going to do, just in case we have something else on the ground that we want to put underneath of it, I'm going to do 3. I might even do something a little bit higher, like 5 or 6. And then potentially things like particle effects and stuff like that could even be higher still, like 10 or 11, so they show up on top of the tank. But what this should do is this should at least show us, and we should be able to now see our tank, frankly, speeding through this map. 10 was even 10 was a little too fast, I think. But we can now see our tank, and it is just whizzing through there. Okay, so all is good, except for we now get this error here. And it spams us as soon as we hit the end. It starts spamming us, index out of range exception. The index is out of the bounds of the array. And the reason it's doing that is if we look at our code, and I kind of called this one out earlier and saying, hey, this is going to be an issue. We keep on adding 1 to current waypoint. And when we were talking about arrays, I mentioned once you get past 18, you can't see it anymore. So this last one, I'm looking for waypoint 18. I'm moving up this scale, but once I hit 18, I'm gonna end up stuck, right? Because now I'm looking for 19. 19 doesn't exist, and that's where we start getting a crash. Okay, so there's 2 ways we can fix it, and I want to show you how to make a closed loop first. And the reason I want to show you a closed loop, it's not right for this particular project, so we'll end up changing it to the other thing. But what I'm going to do now is I'm going to change this. So instead of being a loop, or instead of going to here and stopping, I'm going to make it loop. So I'm going to have it go, when it hits 18, I'm going to have it move to 0. Now, a lot of people are going to show you a trick that says something like code like if current position. Actually, I'm just going to type it out. A lot of people would do something here, and you can either type it or not, but I'm going to erase it in a second, so it might not be worth your time to type. But a lot of people would have you do something like if current waypoint equals 0 or equals, 19, Actually that should be equals 19. Then change the current waypoint to 0. And that works. It's okay. But what I like better is because the number of waypoints might change. Actually, let me undo that. The number of waypoints might change, which means I'm constantly updating this 19 to other numbers. It's one more thing I can forget about. And this waypoint 0, so if this number changes, it's going to cause me some trouble. So what I'm going to do is I'm going to just get rid of this, and we're going to look at this with our head in just raw math. And there's we've talked about this before. We talked about modulo in one of the earlier tutorials. I think we've talked about modulo in one of the earlier tutorials, but basically modulo is a type of division that is only going to give you the remainder. So if you think back to like 3rd grade math when you learned about division, you probably didn't learn how to do decimals when you did long division. You probably learned about remainders. And so what we're going to do is we're going to take this current waypoint and we're going to say, instead, we're going to say current waypoint is going to be equal to the current waypoint plus 1, which is the same as plus plus, but now, again, the parentheses are going to matter here. Now, because it's in parentheses, we can do modulo. That's what the percent sign button does. It does modulo, which is going to give me, again, division with remainder. And we're going to do modulo, for now, let's do modulo 19, because that's how many objects are in there. And now what this is going to do is it's going to say, hey, we're going to add 1 to our waypoint. We're going to divide that by 19 and take the remainder. So I want to talk through how this is going to work with normal numbers. So if I'm at 2, my current waypoint is 2. That's going to put me at 2 plus 1, which is 3. 3 divided by 19 is 0 remainder 3. So it's just going to be, because the modulo is looking for the remainder, it's just going to give me a 3. It's going to say current waypoint is 3. Everything is wonderful. That's perfect. But when we get up to 18, that's when things are going to get a little crazy, because I'm going to go 18. 18 plus 1 is 19. 19 divided by 19 is 1 remainder 0. That's going to take this current waypoint and set it to 0 instead. So it's automatically going to loop. And so if we run this, I'm just going to run it one time, and then I'm going to show you one more trick that's going to make this code even better. So again, we're going to run this, and what it should do is get all the way to the end and then loop. So he's going to go back to, oh, nope, he didn't. Index was outside the bounds of the array. Did I forget to save? I think I forgot to save. I did forget to save. Okay, it's very important to save your work when you're coding, otherwise Unity doesn't get the updates. And if you're not sure if stuff doesn't work the way you think it should have, definitely go back, save it, and come back in. I know a lot of people who are like, oh no, what code mistake did I make? And they'll keep on editing it, keep on editing it. I'm like, did you save? And it turns out that they had just forgotten to save. So we're going to go ahead and go through. Again, we're going to run this. And again, after he goes through all these little twists and turns, he should run back to the beginning again. Hey, there we go. That's what we were expecting to see. Okay, so now we have a loop, and he's just going to stay on this. Now, there's one more thing that we want to do to this, and we're going to try to make this extensible for later in case we decide to change things. Oh, I don't like this map. I do like this map. This 19 is bad. But what we can do is we can take and say, hey, how many waypoints are there? And just ask that question. So that way, if that number of waypoints changes over time, we don't have to update our code, which makes it easier if you're working with a game designer or somebody else who doesn't know code. We're just going to make this work. So we're just going to do waypoints.length. And in this case, the length is not the actual length of the waypoint. It's the length of the array, which again currently is 19 items. So this is going to effectively be modulo 19. But if I add or subtract waypoints, they're going to just get factored in. And I'm going to go ahead and demonstrate that with an extra waypoint, and then I'm going to delete that waypoint, so you don't need to follow along. But let's go ahead and save that. And what I'm going to do here is I'm going to go ahead and create well, first off, I want to show that it works. So we're going to go ahead and run this once. Okay, so again, our tank is going to run in as soon as the rainbow swirl stops. Okay, our tank is going to run in, and it's going to go back to start, and it will repeat this pattern forever. We don't need to sit through that. But here's the cool thing: is I'm just going to take this waypoint 18, and I'm going to duplicate it a couple times here. And so now I've got waypoint 19, and I've got waypoint, I want waypoint 20. We're going to create waypoint 20 is going to be, I don't know, up here. And I'm going to go grab this waypoint 21 and kind of move it here. Let's move it like over there. And then I'm going to go back to my tank. And now that we're up to waypoint 21, I'm going to say 22. We added room for a few more down here. And I'm going to grab 19. And you don't need to follow along with this if you don't want to. 20 and 21, because I'm just kind of trying to prove the point about modulo and lengths. So now he should bounce around with those extra waypoints, and then we're going to delete those in a second anyways. So again, here we go. I'm bouncing through. Isn't that great? Yay, go back to start. Okay, now I'm hitting all those other weird waypoints and then going back to start. So using a combination of dot modulo and dot length didn't really add much to the length of my code, but it gave me this functionality of creating this closed loop that I wouldn't have had before. Okay, so now I'm going to go ahead and just get rid of some of those extra points. Again, I added 19, 20, and 21 here, so I'm just going to delete those. And then I'm going to go into my tank because now I've got some problems. And if I run right now with these missing transforms, I definitely would have some issues. But I'm going to scale back down from 22 to 19. That's going to delete those extras. And now I should be in good shape. Okay, so now I'm back kind of where I started. Now, in reality, this is a great way to do things. But normally in a tower defense game, so if you want a patrol to be like a circular patrol, I'm going to go around this square, I'm going to go around this thing, or I'm going to go through these steps as a patrolling enemy, maybe in a like an RPG game or something. This is fantastic. But what I really want is I want him to get up here and theoretically stop or get destroyed or something. For now, I'm just going to have him stop. But I definitely need to get him there so he can stop. Okay, so what I'm going to do here in my code is we're going to shift things out a little bit. And I'm going to, instead of doing this modulo method, we're going to kind of revert back. So I'm going to disable this one and say this is for loops. And then I'm going to add another comment here and say, if you want to stop. Okay. And we're going to go back in. I'm going to copy this other line of code here that we did previously. And actually, I'm just going to revert it back to the ++ method that we had a long time ago. So here where it says current waypoint equals, we're just going to delete all that and go back to only doing a ++, because again, we want to stop there. And now what we're going to do is only have it move if we're hitting the correct spot. So, so actually this is going to be number 2. If we want to stop, what we're going to do here is we're going to add an if statement. So we're going to say, hey, if we're only going to do any of this code if my current waypoint is less than waypoints.length. So if I'm looking for number 18, there are 19 in the thing, I'm good. If I start trying to look for 19, 19 doesn't exist because, again, we start counting at 0, and it's not going to work. So this is going to make us stop. And this is great. So if I save this, This should give us a very similar experience to what we've been seeing. And again, it does adjust itself as I adjust the number of waypoints in my map. Again, as long as I adjust the number in the array as well. But we're going to go ahead and hit play through this as soon as it warms up. Come on, tank, you can do it. There we go. Yay, he's going through, and we should get him to stop. And there we go. Oh, it's still trying to go outside the bounds of the array. Why is it doing that? If current waypoint... Did I not? No, I saved it. Hang on a moment. Let me look at this real quick. Oh. This stop code needed to be up here, not down here. So this is going to be, I'm sorry, I made a mistake. If you want to stop, you need to use this code. But I put the if statement in the wrong spot. So there we go. Okay. The if statement actually needs to be an update. I'm sorry. Let's try that again. You want to go if current waypoint is less than waypoints.length. I was editing the wrong chunk of code. And we're going to put that around this. And now we can save it and it should work. So we've got okay, because now we're only going to be trying to move towards the waypoint that we can actually see. And once we hit the top, hey, look at that, he stopped. Now, alternatively, if I wanted to, I could add an extra piece of functionality where if I hit the last one, which this would be normally true in a tank kind of a game, I could do some things like subtracting score, adding damage or whatever, because that's what a tower defense game would typically do here. So I could add an else statement here. So basically, if the number got too big, that tells me I ended. I'm at the end. So I'm going to add a little comment here. And so what I would maybe want to do here is damage the player, lower score, etc. You know, whatever I want to have happen here. But I also want to just destroy the tank because I don't want it, I don't need that game object existing anymore. So I'm going to go ahead and just do destroy on my game object. And that's going to teach, or that's going to go ahead and terminate the tank. So I'm going to go ahead and save that. And we're going to go ahead and run. He's looping through, and what we should see is at the very end, he terminates himself. Okay, so now we've got a nice setup for any other ones. Now, the last couple things I would want to do here is just a little bit of, you know, prettiness cleanup. I think that the tank's speed of 10 is still a little excessive. I'm going to bump that back down to 3 again. Let's just see how that works. I think 3 is feeling a lot more like a tower defense game kind of a speed. Honestly, it might still even be fast. I might even bump that back down to 2. But now the last thing that we're going to fix is you can also see that the tank's direction doesn't seem to change, which is just fine as we come up against this straightaway here. It's just fine right now, but really by this point, he shouldn't still be facing to the right. He should be facing up. And one of the things that we want to make sure that's going to make what we're about to do way easier is anytime you're designing a sprite that needs to be able to rotate, you should always make it face to the right. So like if we're thinking about top down, it should always be facing the right. If we are trying to make it rotate in a circle, it should be right. If you're going to be able to flip it, it should always be facing right. The only exception is if something is going to go up and down, but only up and down, you should have it facing up. Okay. And the main exception to that is, like, for example, in the previous animation set lesson, we had a separate animation for left and right. In that case, we're not actually rotating a sprite. We're using a different animation set. So obviously we would want to have that be facing to the left. But if we're going to take a sprite and rotate it or flip it, you always want it facing right if it needs to do either right, left, or 360 motion, or facing up if it's going to be doing up-down motion. So those are the two that we want to be paying attention to. Okay, so now that I've got this, I am facing to the right, which is good. What we're going to do is we're going to learn how to rotate. And the rotation code is really pretty easy. What we're going to start out with is we're just going to update this tank. What am I trying to say here? This tank script just a little bit. We're going to add a rotation speed. So we're going to do float rot speed. Rot is my abbreviation for rotation in just about everything. And we're going to start that at about 30F. And that's going to be pretty good. You don't necessarily need to use F with whole numbers, but anytime you're doing floats is a good idea. I probably should have done that here too. We're going to change that to F, even though that's now 3, but whatever. Okay, so we've got our rotation speed. And in this case, rotation speed is going to be how many degrees can I rotate per second. So this is going to allow me to rotate about 30 degrees per second. It's going to be a little slow, actually, but I want you to be able to see the rotation. And then what we'll do is we'll switch that. We'll increase it to about 120F is actually one that looks a little bit more natural, but we're going to stick with 30 for now, just so that way we can see the movement happen. Otherwise, it might just be too subtle. Okay, so what we're going to do down here is under our update function inside of this if statement, because we're really only going to need to do that if we're moving, we're going to add one more line of code. And this one is pretty easy. We're going to do transform.write. Because transform.write is the x-axis, is the x handle, basically, of our tank. So if we look at this in a more figurative idea, what I want to do is I want to take this handle, let's zoom in on my tank a little bit here, and if I rotate, what I'm really trying to do is I'm trying to take that x rotation and move it, so it's like facing a different direction, so now it's facing this way instead. Okay, and so the more I rotate my tank around, that X movement or the X arrow will always be pointing forward for me, and that's really what we want to see. So we're going to be adjusting the the transform.write, which is our X, to be facing the direction, basically always pointing towards our waypoint. But we want to get there gradually. We don't want it to be instantaneous, because then you just see this like sudden change. It doesn't feel natural. We're going to actually have it rotate in to those alternate rotations. Okay, so now that we kind of get the gist of what we're trying to accomplish, let's take a look at the code. So we're going to take our transform.write, and we're going to use the vector3.rotate_towards method. Now, vector2 doesn't have a good method for this, so we're just going to use vector3. And this is why it's important that all of our z's are 0, because then the z's just won't factor into our equation at all. If the tank is on 0 and the waypoints are on 0, then there just won't be any z rotation, and that's good. Okay, so rotate towards, we're going to do transform.write. Again, that's our starting point. Our target is we want to be facing the direction of, or we want to be pointing towards the target. The vector that represents the target, or facing towards the target, is basically if we take the target's position, which again is waypoints, current waypoint.position, and we want to subtract our position. Waypoint, or no, I'm sorry, whoops, that's just transform.position. So we're going to subtract our position, and that's the direction that we intend to face. Okay, so whatever its direction or position minus our position is, that's the direction we're trying to get to. And then we are going to do that by taking our rotation speed and multiplying that by time.delta time. And the last thing we need to do is a magnitude adjustment, which is required for the function, but we don't actually want to mess with the magnitude delta. So we're just going to put a 0 in there and call it good. And then we put in our semicolon and we're good. And I realize that this line of code has turned pretty long. So I'm going to just manually add a breakpoint. I like to do it after the commas. So we're just going to, oh, there we go. That looks nice. So we're going to do, again, this is one line of code really, but if you break it, it's okay. We're going to do rotate towards. We're going to take my transform.right is the starting rotation. Their position minus our position is the destination rotation. We are allowed to turn no more than rot speed times time.delta time. And we are not going to mess with the magnitude of any of these vectors at all, which is way more advanced than this tutorial is intending to go. So we'll just leave that at 0. Again, we're going to save that. And it's actually, I left my tank rotated improperly. This is actually going to be a great initial test because if the tank starts rotating towards that first waypoint, then we know we've done it correctly. So we're just going to go ahead and watch the tank rotate. And what we want to see is a gradual rotation. We don't want to see that go instantly. So as we run it, we are seeing that tank kind of rotate. And he's spinning pretty fast, but he is spinning. You can see a little bit of a transition there. But I actually want to slow that down a little bit just so we can see it. It's going to look a little bit less natural, but that's okay. So we're going to change our rotation speed. I'm going to change that down to like a 10. This is honestly not going to look good, but it'll be okay. So we'll at least be able to see that our code is working. So as we look at the tank, you actually see it turning, which is good. That's what we wanted to see. It looks like it's an actual turn instead of just a snap. And actually, it doesn't look as bad as I was thinking it would, so I might just leave it at 10. It does get a little bit weird because he's... actually, that's not even noticeable, so that's pretty good. I'm pretty happy with 10. You could even lower it a little bit further. The problem is if you lower it too much, you're still kind of facing this way, but you're moving this way, and it starts to get a little bit distracting. So there's a fine balance, trying to zero in that that speed. Okay, so that's it. We've now learned how to rotate. We learned how to follow a waypoint system. We learned a little bit about arrays. We learned how to destroy an object when it hits a certain position. We learned how to do a move towards. We learned how to rotate towards. We learned a little bit about trigger colliders. So we've actually covered quite a bit of ground. I am going to be doing, just to give you guys a preview of what's coming up, I'm going to be doing a tutorial on 3D pathfinding and waypoints, probably 2 sessions from now. But we are going to use NavMesh for that, and I adore NavMesh. I think it's a fantastic utility. So if you want to learn a little bit about NavMesh, please come check that out. In the next tutorial in this series, or in the next tutorial for this, we are going to come back to tower defense, and I'm going to show you guys how to spawn additional tanks, and we're going to retweak where our waypoints are stored so that way we can access them more generally. So we're going to make a few little adjustments to this program, but we're going to learn about spawning more tanks, and maybe even keeping a score at the end for how many tanks have managed to get off the screen. I guess that'd be more like a hit point check, but that's okay. All right, so that's about it for today. If you like this tutorial, please like and subscribe. And as always, when we close, keep on creating. Have a great day, guys.